This view of Earth represents our baseline. For us, a year is a fixed rule of planetary physics. It's the time it takes for our planet to complete one full orbit around the Sun and cycle through all 4 seasons. But 31 light-years away, there is a planet that operates on a totally different scale. It's called GJ367b, and a single year on this strange world lasts exactly 7.7 hours. Think about the temporal reality of that speed. Between the time you wake up in the morning and the time you go to sleep at night, an entire planetary year has already started and finished. To complete an orbit in roughly 8 hours, a planet has to be located dangerously close to its host star. Astronomers didn't capture a direct photograph of the planet, but they observed this exact physical mechanic. When a planet passes between us and its star, it creates a dark silhouette that blocks a tiny fraction of the light, a technique known as the transit method. This chart visualizes that exact discovery data. The line shows a horizontal light curve that repeatedly dips at highly compressed 7.7-hour intervals, proving the planet's incredibly tight orbit. If you placed a normal rocky planet into an orbit this extreme, the immense gravity and stellar heat would vaporize it or tear it into debris. Yet GJ367b remains intact. This diagram maps the physics keeping the planet in motion. According to Kepler's laws, as an orbit shrinks, planetary velocity must increase proportionally. And notice the continuous bombardment. That extreme speed requires the planet to fly through intense, relentless stellar radiation. This proximity pushes the star-facing side of the planet to temperatures between 1300 and 1500 degrees. Under that level of thermal stress, standard planetary materials fail. Solid rock and even heavy metals lose their solid state and begin to melt. To survive a heat environment that actively liquefies normal crust, GJ367b must possess a highly abnormal structural makeup to avoid completely disintegrating. Measurements confirm that while the planet is roughly 3/4 the size of Earth, it has an extraordinary density. This image of Mercury provides a visual anchor. GJ367b is effectively a cosmic cannonball, dominated by a disproportionately massive solid iron core. Planets do not naturally form as exposed iron cores. This world originally possessed a thick rocky mantle, meaning vast amounts of its outer layers have been completely removed. One explanation is that billions of years of intense stellar radiation boiled away the planet's original rocky mantle, aggressively blowing it out into space. Another hypothesis points to the violent, chaotic history of young planetary systems, where massive early collisions physically smashed the outer shell off the planet. Regardless of which violent event stripped the planet bare, that exposed, dense iron core is the exclusive reason it possesses the structural integrity to survive the star's immense gravity today. The star's immense gravitational pull forces another extreme condition on the planet. It causes a phenomenon called tidal locking, meaning the planet's rotation perfectly matches the speed of its orbit. Because of this, one hemisphere of the planet faces the star constantly, enduring permanent, eternal daylight and molten heat. The opposite hemisphere points permanently outward into space, trapped in a frozen, eternal night that is completely shielded from the star. Without an atmosphere to distribute the heat, the planet does not have a unified climate. It is a single world cleanly divided into 2 hostile, irreconcilable extremes. When we zoom out to the broader context of the Milky Way, worlds like this provide a harsh lesson about planetary system formation. This cross-section highlights a literal physical threshold in space. Get past this dotted boundary line, and a star's tidal forces and radiation transition from extreme to fatal, tearing planets into debris. The quiet, stable conditions we experience in our solar system are an exception. The broader universe routinely builds worlds in incredibly violent environments. GJ367b exists perfectly on the knife's edge of that destruction boundary, surviving only because it wears heavy iron armor. In fact, in the 5 minutes it took to watch this video, that small glowing hot rock has already progressed significantly through its orbit, ticking away yet another 8-hour year.